All right. Now today we're going to do chapter 5, section 5 and 6 because we actually did this section last class. I went through all the properties. This is just we're just going to do some examples of them, and that what the next section is going to be is solving exponential and logarithmic equations. So we should be able to finish both of those today with no problem. And remember, Wednesday it'll be only online because I'll be at my conference doing a presentation. So no physical class, will be virtual only. All right. The first the properties. Let's look at example 1. Prove or show that log base a of 1 is equal to 0 and log base a of a equals 1. These are the first two properties. How would we prove them? What we have to remember is how to convert them into exponentials. So there's your logarithmic equation, and the conversion of which is a is still the base. It pushes up the answer. If the base is gone, log drops off, and you get x. This we'll use whenever we do any conversions between exponentials and logarithmic equations. So with this, we can prove the first one. The a comes over here. A to the 0 is 1. That's true. Anything to the 0 power is 1. Check. Same thing here. A to the first power is a. Also check. It's just a common sense one. The next two is a to the log am is equal to m, and log base a of r equals r. With this property, this one goes to the property, since the bases are the same, the exponent, the answer goes out in front. It goes m. Because a log a of x, these cancel, we just get x. The proof of which is we could take the log of both sides, and then that ln a goes in the front. Likewise here. The rule of this one says the coefficients go out in front. So we have r log a of a. Up here, we learned log base. If the base and the operation are the same, it equals 1. So r times 1 is equal to r. So that's how we prove those. True or false? True, because since the bases are the same, pi equals pi. Log 0.2, 0.2 to the power negative radical 2 equals negative radical 2. The exponent goes out in front. That becomes 1. So we have negative radical 2 equals negative radical 2. Check that works. Why is that one true? What is ln? How do we expand ln? You said you had it. ln is log base e. Since they're the same, the exponent goes out in front. Log base e of e is 1. So kt equals kt. I heard you say e earlier. You were right. So far, so good. Now let's look at the next 4 properties. Log base a of m times n. Remember, we talked about this last week as well. Whenever you have a product, we can expand them by adding the individual logs. Let's derive this one. Let me don't see where it came from. A fraction, we can rewrite it as m, in this case, times n to the negative 1 exponent. Now we have a product rule. This exponent goes out in front, so it becomes negative log base a of n. So whenever you have a subtraction or a division, it becomes a subtraction because it makes things smaller. Eventually, what you'll see is if you have a negative in front of the log, that operation is going to be on the bottom. If it's got a plus, that's going to be on top. For example, what if I gave you this? I'll use ln. Write that as one function. Ln of m minus ln of n minus ln of x plus ln y minus 3 ln a plus 2 ln of 5. Here's a fast way of doing it. They're all ln's, right? If it has a plus in front of it, it goes in front on top of the dividing line. If it has a minus in front of it, it goes on the bottom. So it's m n x y. This goes up there, so it's a to the 3, and this is 5 squared. This is an exponent. Any coefficient become exponents. So if you see a bunch of plus or minus ones, it's just anything that has a minus, that goes on the bottom. Anything has a plus, that one goes on top. Well, yeah, because that's, remember, the rule is yeah, the only thing you can do is make that into a 25. Other than that, as far as you can go. Because yeah, I know what you guys are probably doing is going piece by piece by piece, but in the long run, it's just shortcut. If they're all ln's, all the same operations, if it's got a positive, it's going to be on top. If it's minus, on the bottom. If not, then if it's all positive, then it's one big product. Log of a mn. This is the rule of the coefficient. This rule is pretty interesting. Why is that a true rule? R is a coefficient. Where does the coefficient go? On top of the a. So we have e ln a to the r. Ln is log base e, since the base and the log of the base of the log is the same, they cancel. Look at it. Okay. So those are the properties. Let's expand them now. Let's do some examples. Right, log base a of x times radical x squared plus 1, where x is positive. I should say expand. Expand that function. It's a product, isn't it? This is the F, or this is the M, and this is the N. So what do you do when you have a product? So far, so good. Since it's a product, what do you do with the radical? Remember, the conversion of radicals are these. So here's a log. The exponents go out in front. And there you go, as far as you can go. Until you know what X is and what A is. Expand this function. Where X is greater than 1. Here's a question. Why does X have to be greater than 1? Is that if it's 0, then we have a negative on the bottom. Then we can't take a logarithm of a negative number. Remember, the graph of a log function looks like this. We cannot use any negative, so we cannot take the log of a -2. So that's why this has always got to stay positive. And the way to do that is making X bigger than 1. As we said earlier, if you have a fraction, whatever's on top has a positive in front of it, whatever's on the bottom has a negative in front of it. This exponent goes out in front. This exponent goes out in front. And that's as far as we can go. We cannot separate these. There's no plus or minus rule. Okay, example 5. Expand this function. So X has got to be positive. I can tell you where you're messing up already. All right. On the top, we just have log base A of radical x squared plus 1. And these are on the bottom. This is a product. So we have to do it, separate those. Remember, that minus sign, when I expand this, is still out in front. Because this minus sign goes to both of those. So I distribute, I get minus log base A of x cubed minus log base A of x plus 1 to the fourth. Again, both of these are on the bottom, so they have to have a minus in front of them. This comes to the power 1/2. All the exponents go out in front. And there's your answer. Yeah, if you have a rational expression, whatever's on the bottom will have a minus in front of it. Whatever's on top has a plus in front of it. And then we just make sure we have all the exponents taken care of. We don't touch this one because it's inside the parentheses. How does everybody feel about that? That's expanding them. Let's go backwards. Let's start constricting them. Write as a single logarithmic expression. Log base A of 7 plus 4 log base A of 3. Can you do anything in the first one? No. How about the second one? What? This 4 goes where? Goes as the exponent of the 3. Since it's an addition, and they're both log base A, I can multiply them. Three to the fourth is 81. We get 567. If you go further with the exponents and the radicals, whatever, go forward. Go do it. B. There is no wrong way to start. As long as you follow the rules of math, you can start wherever you want to. Or inside here, we can work that one out. 5 squared is what? Minus 1. What do we do with this exponent here? What is the coefficient? Yes, it becomes an exponent. Since they're subtracting, I'm going to divide. 8 to the 2/3 is the same thing as 8 to the power 1/3 times 2, or cube root of 8 squared. Cube root of 8 is 2. 2 squared is 4. And you simplify that. So far, so good. Can we go any further? Because this is the ratio. So we can go ln1 minus ln6. ln1 is what? 0. So the answer is negative ln6. Out of all of mathematics, this is probably my most enjoyable part of it, because it's a puzzle, it's a game. Expanding, building things, disassembling things. Any questions about this one? All right, let's try a bigger one. Log ax plus log a9 plus log a x squared plus 1. Actually, that's similar to what I just did. Remember, whatever has a plus in front of it goes on top. Whatever has a minus goes on the bottom. If they all have pluses, or if they all have minuses, they're multiplied together. Since they're all log base A, and there's some of them have pluses, one of them has a minus, so it's going to be a fraction. Everything that has a plus in front of it goes on top. So we have x, 9, and that. So it's 9x, x squared plus 1. Whatever has a minus in front of it goes on the bottom. We can leave it like that, or the only thing further we can do, which is not really much, either one of them. So if it has a plus in front of it, that argument goes on top. If it has a minus, that one goes on the bottom. Conversely, if you have a fraction, everything that's multiplied on top will have its own log, but they have a plus between them. Whatever's on the bottom will have its log, but has a minus in front of it. How would you expand that one? Okay, so all of these on top will be separated by pluses. All these on the bottom will have a minus in front of them. That's all there is to it. All right, here's a statement. Which one of these two are correct for that one? You cannot, if it's a plus or minus inside the parentheses, you cannot expand it any further. Only if it's multiplication division can you expand it. So if you have a difference or a sum in an equation, that's as far as you can go with it. How about this one? First one or second one's correct. They go straight from the property. This does not exist. We'll get to this in a second, but not like this. How about the last one? Can you do this? Or do you have to leave it like that? There's a difference with this one. This one says the whole thing is raised to a power. This one, only the m. Then we can do that. But if the whole thing is, you can't go any further. You can't distribute it inside there or anything. It is what it is. Any questions so far? Approximate that. We cannot do anything with a calculator with that what we have here, because calculators in our computers only do these two operations: log base 10 or log natural. So what we have to do is something called the change of base. We can't have a 2 there. The change of base is we could either leave it as a base 10 or a natural log. Because it's the ratio that's important, not the actual values themselves. It's the ratio of those two values. So for this one, we would have to change it to something like this. And then we can use the calculator to do the difference, or the quotient. You put that in your calculator and whatever gives you the answer. Do the change of base for both of these. So the first one, what'd you change it to? Mm-hmm. And you plug that in your calculator, whatever the answer is. So whatever is out here goes on top, the base stays on the bottom. So this one, that's all the change of base does to you. The reason I use ln is it's a lot less writing than log. I save it by one letter. I'm saving my ink. That's it for that section. Pretty easy. Again, we did most of this stuff earlier.